So, have you ever wondered how your AI assistant seems to remember everything you tell it? I mean, it can recall project details from weeks ago, your preferences, your goals. But here's the thing, that memory is basically an illusion. Today, we're going to pull back the curtain and look at the engineering architecture that makes it all possible. You talk to your AI, right? You tell it your preferences, you give it details about your projects, your goals, and it just seems to remember it all. But how? Is there some tiny digital brain in there storing every single word you say? Well, the reality is actually way more interesting than that. Okay, here it is, the big secret. Large language models don't actually remember anything at all. Every single time you send a message, the model is starting from a completely blank slate. It has zero persistent memory of what you just talked about. You can think of it like a pure function. Text goes in, text comes out, and the past is just gone. So what does stateless really mean in practice? Well, imagine talking to someone who has no short-term or long-term memory. You would have to reintroduce yourself and explain the entire context of your conversation every single time you said something. That's exactly how an LLM operates on its own. The memory you think you're experiencing is actually a really clever trick. It's not done by the AI model itself, but by the application wrapped around it. Before your message even gets to the AI, the app is behind the scenes, silently stuffing a massive prompt with your user info, snippets from old chats, and your recent conversation. The LLM sees all this information fresh every single time, and that creates the powerful illusion that it actually remembers you. So if the application is handling the memory, how does it decide what to show the LLM? Well, there are two main ways to do it, two dominant architectural patterns, and we can think about them with a pretty simple analogy. Are we going to hire a meticulous librarian, or are we going to use a powerful search engine? So on one hand, you have the librarian, which is our context tree. This method is all about carefully organizing a curated collection of knowledge, stuff that a human can easily read and edit. On the other hand, you have the search engine, our vector database. This thing is built to instantly search a massive unstructured archive based on meaning, not just keywords. Let's break down each one.
All right, first up, the librarian. This strategy is all about structure, curation, and control. It's the perfect choice when you want your AI's knowledge base to be totally transparent and something you can manage directly.
You know, the power of a context tree is really in its simplicity. It's literally just a folder of text files organized in a hierarchy, just like the files on your computer. You might have a core folder that holds info that should always be remembered, like your name. Then other folders for projects or topics that only get loaded when they're relevant. It's so intuitive, and you can actually go in and read every piece of its memory yourself. So how does it actually work? Well, it's a really smart, multi-step process. First, the system always loads that core memory. Then, it reads your message. And here's the magic part. It uses the LLM itself to figure out which branch of the tree is relevant to what you're asking. If you ask about a project, it only loads that project's files. This is incredibly efficient. It saves thousands of tokens, and that saves money by not loading up a bunch of junk that doesn't matter. Now, for anyone out there with a computer science background, this might be sounding a little familiar. You might be thinking, hey, this sounds a whole lot like a B tree, the classic data structure for database indexing. But are they really the same thing? Nope, not at all. And this table brilliantly shows why. A B-tree navigates using mechanical comparisons on sorted keys. It's looking for an exact match. But a context tree? It uses a large language model to navigate based on semantic relevance to a normal, natural language query. It's kind of the difference between a database index and a library catalog. One is built for machines, the other is organized for human-like understanding. Okay, let's switch gears. If the context tree is our neat, curated library, then the vector database is like a ridiculously powerful search engine that's designed to find a needle in a haystack of millions of documents. The core tech here is something called vector embeddings. It's a way of turning text, a word, a sentence, a whole document, into a long string of numbers. But here's the trick. Texts with similar meanings get turned into similar sets of numbers. This allows the system to search for concepts and ideas, not just for specific keywords. So what's the trade-off? Well, the upside is massive scale. It's fantastic for those kind of fuzzy questions like, what did we say about pricing last month? The downside? Well, the process of creating these number representations, these embeddings, can be lossy. You might lose some of the nuance from the original text. Plus, it requires its own dedicated infrastructure to run, which can be complex. But look, Having a storage system is only half the battle. A memory is totally useless if it's wrong or out of date. And that brings us to the super important job of curation, deciding what to remember, what to update, and maybe most importantly, what to forget. An AI's memory needs a formal set of rules, just like a regular database. We need rules for when to create a new memory, when to update an existing one, when to merge notes that are redundant, or when to delete information that's just not true anymore. This disciplined approach is what keeps the AI's knowledge from becoming a total mess. And here's a crucial point. Not everything is worth remembering. A smart system uses a filter. So when new information comes in, it asks a series of questions. First, do I already know this? If yes, skip it. Can I figure this out from existing files? If so, skip it. Is this only useful for this one moment? Skip it. Only if the information is new, lasting, and genuinely helpful for the future does it get saved as a permanent memory. Okay, so we've covered the different architectures and how to maintain them. Now for the most important part. How do you actually apply this? Which system should you pick for what you're trying to do? If you're building a personal AI assistant, the context tree, using just simple text files is absolutely the way to go. It costs nothing to set up. You can literally open a file and edit your AI's memories directly, and you have complete transparency and control over what it knows. It's a no-brainer. But if you're trying to query a massive library of documents, like a whole company's knowledge base, then a vector database is the clear winner. This strategy, often called RAG, or Retrieval Augmented Generation, is purpose-built for doing those fuzzy, meaning-based searches over huge amounts of text. And for a coding assistant, the ideal approach is actually a hybrid. A context tree is perfect for navigating the structured folders of a project's files, while specialized code-based indexing helps it actually understand the code itself. You really get the best of both worlds, architectural understanding and semantic search. Ultimately, this is the main takeaway. Whether you choose a simple folder of text files or a complex vector database, the goal is exactly the same. The best system is one that isn't a black box. It's one where you can see what the AI knows, you can fix it when it's wrong, and you can actually build a sense of trust in its knowledge. And that leaves us with a final thought. Memory is the foundation of intelligence, both for us and for AI. So the real question isn't if your AI will have a memory, but what kind it's going to be. Will it be a carefully designed garden that you can tend to, or will you let it become an overgrown jungle that you can't control? The choice is yours.
If you found this helpful, hit subscribe and the bell so you never miss a video.